Okay, so we cannot square root a negative, so what kinds of values are not going to work? So if you forget how to do this, we could just think about numbers. So for instance, is 8 good? Yeah, 8 is good because 8 subtract 0, or 8 subtract 8 is 0, and we can square root 0. What about 9? Would 9 be good? 9 subtract 8 is 1. I can square root 1. What about 7? Would 7 work? No. 7 subtract 8 is negative 1, and then we're not going to be able to square root that. So you could make this statement. X has to be greater or equal to 8. Or you could make this statement. X cannot be less than 8. Either one works for me. You can make this statement that says X has to be this or X cannot be that. Okay, multiplying. So on this one I squared something. So what does it mean to you to square something? It means you're going to have to write it out twice. Okay, that's creating a whole FOIL now. Okay, a FOIL. So first times first, you're going to get a whole number 4 root 25. And if some of you want, at that stage, you can already write the 5. I'm going to do that next, but outside, this would be a negative 12 root 10. Insides, negative 12 root 10. Last, plus 36 root 4. Okay, so now we're going to simplify. So this root 25 is the same as the whole number 5. So that value is 20. 36 times root 4 is the same as timesing it by a 2. So that should be 72. And these are both root 10s, so I can add them up together. So negative 24 root 10. Okay, now I can also do more combining. I can put the 20 plus 72 together, making 92 minus 24 root 10. Okay, rationalize the denominator. So this means you don't want to have a denominator in the bottom. So this one is called the monomial one because there's only one term on the bottom. So if I have a monomial, I'm just going to times it by a root 6. To get rid of the root 6 on the bottom, I'm going to times it by a root 6. Okay, and then we learned that what you do to the bottom, you do to the top, so that you're essentially multiplying by 1. Okay, so the top is going to create a distribution. So each one multiplied by root 6 makes root 42 subtract 4 root 30. And on the bottom, it's a 2 and a root 36. So this is 2 times 6, which will be the number 12. So when I have an end on those my bottom is not going to have any radicals in it whatsoever now. And then I would double check, does 42 or 30 divide by any magic numbers? Are they divisible by 4, by 9, by 16? Is 42 divisible by any of those? I don't think so, right? Because it's not divisible by 4. 30 is not divisible by 4 or 9. So then I'm good. Okay. The next one is a binomial on the bottom. So we had a really fancy word. We're going to multiply by the conjugate. So root 6 plus 5 root 5, because I have to repeat it but with an opposite sign. There's got to be a plus minus going on in that. Okay, so on the top here, 2 binomials we are going to have to FOIL. So first times first makes 2 root 18 outsides make 10 root 15. 10 root 15. Insides make negative 3 root 66. And last makes negative 15 root 55. Okay. Now, what's really special about the FOIL process of a conjugate? Remember how we can cheat? If you've set up your conjugates properly, those will cancel out. They'll make 0 when you do them. So we get to cheat, and we get to do just the FLA. So first times first is root 36. This should always be a subtract, because 1's plus, 1's minus. You're always going to have a subtract. Whole number, 25, root 25. So this is a 6, subtract 25 times 5. So 6, subtract 125. Equals negative 119. Okay, before we do our final answer here, I'm going to look at my radicals. 18. I think that's divisible by one of our magic ones, so I'm going to break it down. So 2 and then 18. Instead of 18, I'm going to change it to a root 9, root 2. Root 9 is really the number 3, so this is going to be 6 root 2. $15 is not divisible by anything magical, right? Is 66. Not divisible by 4. Not divisible by 9. So I think we're good. 55. Not divisible by anything either. Okay, and again, when we look at our bottom, there's no rationals in it. Or, sorry, radicals in it. That was our last unit. Okay, breaking down or simplifying. So we have to have all those magical numbers memorized. 4, 9, 16, 25, 36, etc. So 75 is divisible by which one of the magic ones? 25? 25 times 3 is 75. So root 25 is 5, so 5 root 3. Okay, 252. Let's look here. Is it divisible by, ooh, I found one already. I went bigger. You always want to go with the biggest one you can. I think I found that it's divisible by 36. So if some of you figured, oh, it's divisible by 4, okay. It was divisible by 4, but then look at this, 63 could also break down by a 9, right? So this makes me break down by 4 and then break down by 9, and I'm having to do 2 breakdowns instead of just 1. So that's why you can try to pick the bigger one. So this wouldn't have been wrong, but it would have made you do 2 breakdowns. Okay, so 108 is divisible by the biggest one you can find. Did you also find it's divisible by 36? 36 times 3? Okay, so that was just me playing around in my calculator. I started actually like this. I knew it was divisible by 9. But then I thought, oh, well, if I had a 12 there, 12 could be divided by 4. So then I went to 36. Okay, so this is going to be 4 times a 6. Okay, and then the last one, 28, is divisible by 4, right? 4 times 7. Okay, and then the root 4 is 2. Okay, I'm just going to clean these two up here. So negative 24 root 3 minus 10 root 7. Okay, and then what should we do when we are at this stage? We should put stuff together. So how many root 7s do I have all together? How many root 3s do I have all together? So you're going to put them together there. So see what you can come up with for combining them. Did we match? For those of you that did it on your own? So negative 19 root 3 minus 16 root 7. Okay, solving equations. Number 1. What should we start with when we look at that equation? I think I'm going to square right away here. So I'm going to take this side and square it, and I'm going to take that side and square it. Because that's legit. When you do it to both sides, it's still good. Okay, now don't forget, squaring is like seeing this written down twice. So what is the whole number going to be when you square it? 3 times 3 is 9. And what happens when you have a radical times the same radical? The radical part will disappear. Okay, so what do you get on the right-hand side when you square that? So did you get 16 bracket x plus 4? The whole number squares to 16, and the radical squares to disappear the radical. Okay, so I'd like you to now do all your distribution stuff. Whoops, here, I'm not sure what I'm doing. Okay, so now I'm going to collect x's. So I'm going to get rid of 16x because I like to get rid of the smaller one. Then move the 54. Divide, so x equals 5. Okay, so I would highly recommend checking your answers. Sometimes they actually don't work. I feel confident that this one is going to by looking at it, but let's check it out. So if x was 5, 2 times 5 is 10 plus 6 is 16. The root of 16 is 4. 4 times 3 is 12. Okay, so I'm going to remember 12. If I put 5 here, 5 plus 4 is 9. The root of 9 is 3. 3 times this 4 is 12. So it did. It worked. Okay, number 2. I think before you square, you should do some maneuvering of other things. So can you think about the order you want to get rid of some other things in for number 2? So the 5 or the 2 out front, what would you do in the correct order? So I minused 5. And then I'm going to divide by 2. So this for me looks like a good spot to square now, right? Because it will really simplify this side. So I'm going to square to get rid of the radical. So 2x minus 4 equals 16. I'm going to add 4. And then I'll divide by 2. Okay, and you can always check it. So going to check it, if this was 10, 2 times 10 is 20, subtract 4 is 16. The root of 16 is 4. 4 times 2 is 8. 8 plus 5 equals 13. So it's good, it works. Okay, next one. Same process here. I'm going to subtract 10. And divide by 4. Okay, at this point, there's something to be said. What did I talk about when you see the root of something? It's implied the positive of that root. So therefore, the positive of this root could never equal -2. Okay, and the last hardest type. So my first step is that I'm going to subtract 3. Okay, so please be careful here. This cannot be combined together in any sort of way. It's an x and subtract 3. So I get a lot of mistakes there of putting a -3x. That's not what it is about. Okay, now I'm going to square both sides. Does that make sense? Okay, here's the spot where the mistakes can happen. This is not x squared plus 9. How do you square a binomial? You can't forget, it makes you have to FOIL the whole thing. Okay? There's a 100% chance one of these is on your test. So the odds are looking pretty good. You got to FOIL that out. Okay, you can't just square each thing. You're squaring it as a unit. Okay, it's a binomial unit getting squared. Okay, this side is nice. It cancels, so x plus 3. Okay, so I would like you to FOIL that all out. Okay, what do you think we should do algebraically when we see that there's x squareds and x's involved? What do you got to do right away? Make what? One side equals 0, right? So x squared is the boss. So I'm going to keep the x squared and make the other side 0. So I'm going to have to subtract an x and subtract a 3. I'm going to have to subtract an x and subtract a 3. So -7x plus 6. Okay, I think that this looks like it might factor. Does that make sense? Simple trinomial, 6 times 1. They need to make a -7. So x equals 6, x equals 1. Okay. Especially on this one, you better check your answer, because now there's 2 answers. We want to see if they both work. Okay, so here's my original. Right? So every time you see an x, so on this one, I'm going to replace x with 6. On this one, I'm going to replace x with 1. Let's see if it works out. So this would be root 9 plus 3. Root 9 is 3. Yeah, that's good. That works out. Okay, so when I plug 1 in, I get a root 4, which is 2. 2 plus 3 is 5. That one does not work. Okay, so x equals 6 is the only answer.